For thousands of years, humans thought the planets were just wandering lights in the sky. Tiny dots, decorations of the night. But what if I told you that every one of those dots is an entirely different world? A world where metal melts in daylight, where storms larger than Earth have raged for centuries, where oceans may exist beneath miles of ice, and where one wrong step would kill you before you even understood what happened. The strange part? These worlds have been right next door all along. And the more we explore them, the less ordinary our own planet seems. Because our solar system is not a collection of planets. It's a collection of mysteries. And by the end of this story, one question becomes impossible to ignore. Why does Earth seem so different from everything around it? Before we travel across the solar system, it's worth remembering how unusual this journey really is. The Sun contains more than 99% of all the mass in the solar system. Everything else, every planet, every moon, every asteroid, every comet, is simply orbiting this enormous star. Imagine shrinking the Sun to the size of a front door. On that scale, Earth would be smaller than a grain of sand. And yet that grain of sand is currently home to every human who has ever lived. Think about that. Now, let's leave home behind. The first stop is Mercury, the closest planet to the Sun. Most people imagine Mercury as a burning world. But reality is stranger. Because Mercury has almost no atmosphere. Without a protective blanket of air, daytime temperatures can reach hundreds of degrees Celsius. Yet during the night, temperatures crash far below freezing. One side experiences intense heat. The other experiences extreme cold. It's a world of violent contrasts. And despite being closest to the Sun, scientists have even discovered water ice hiding inside permanently shadowed craters near its poles. A frozen secret on a scorching planet. Already, the solar system is breaking expectations. Then comes Venus. If Earth has an evil twin, this is it. From a distance, Venus looks beautiful, bright, smooth, almost inviting. But beneath those clouds lies one of the most hostile environments known. Its atmosphere is so thick that standing on its surface would feel like being deep beneath an ocean. Temperatures are hot enough to melt lead. Spacecraft that landed there survived only briefly before being destroyed. The fascinating question is this: how did Venus become so different from Earth? Both planets formed in roughly the same region. They're nearly the same size. Yet one became a living world. The other became a planetary furnace. Scientists still study Venus because it may reveal something important about the future evolution of planets, including our own. And then we arrive home. Earth. The planet we usually treat as normal. But after seeing Mercury and Venus, Earth starts looking extraordinary. Liquid oceans, a breathable atmosphere, a magnetic field that shields us from dangerous radiation, a climate that allows life to thrive. The deeper scientists look, the more unusual Earth appears. Even beneath our feet, mysteries remain. Thousands of kilometers below the surface sits Earth's inner core, a solid sphere of iron, surrounded by liquid metal. Some researchers suggest its rotation may not always perfectly match the rest of the planet. Imagine that. An enormous metallic heart, hidden beneath continents and oceans, still keeping secrets from us. We often think we figured Earth out. Reality says otherwise. Then comes the planet that has captured human imagination for generations.
Mars, the red planet. At first glance, it looks lifeless. Cold deserts, dust storms, frozen landscapes. But Mars wasn't always like this. Evidence suggests rivers once flowed across its surface. Lakes may have existed, perhaps even entire oceans. Somewhere in Mars' distant past, conditions may have been surprisingly different, which raises an irresistible question. If Mars, could it have supported life? Scientists haven't found definitive evidence yet, but missions continue searching. Not because we expect little green aliens, but because even simple microbial life would transform our understanding of the universe. It would mean life emerged at least twice in one solar system. Let that sink in. Beyond Mars lies a boundary, a region filled with countless rocky objects, the asteroid belt. Many people imagine spacecraft constantly dodging giant asteroids here. In reality, the belt is mostly empty space, but it marks a transition, because beyond it, the planets become truly enormous. First comes Jupiter, the king of planets, more massive than every other planet combined. Jupiter isn't simply large, it's almost a solar system of its own.
Its gravity influences countless objects around it, and its atmosphere hosts some of the most extreme weather ever observed. The Great Red Spot, a gigantic storm, has been raging for centuries. Imagine a hurricane that outlives entire civilizations. Yet Jupiter itself may not be the most exciting thing about this system. Its moons are incredible. Some appear to hide vast oceans beneath icy shells, dark, hidden seas that may contain more water than all of Earth's oceans combined. Worlds within worlds. Next comes Saturn, the planet everyone recognizes. Those magnificent rings make Saturn look almost unreal. But the rings are not solid structures. They're made from countless pieces of ice and rock orbiting together. From afar, they appear elegant. Up close, they're a chaotic swarm of particles. Yet Saturn's greatest mystery may not be the planet. It may be Titan, its largest moon. Titan possesses rivers, lakes, rain, weather systems. At first, that sounds familiar. Until you learn the liquid isn't water. It's methane. An entirely different version of a world. A place where chemistry works according to rules that would seem alien to us. Scientists are so fascinated by Titan that future missions will explore it in unprecedented detail. Because if life can exist in unexpected environments, Titan is one of the places worth investigating. Farther from the sun, sunlight weakens dramatically. And here, we encounter Uranus, a planet unlike any other. For reasons scientists still debate, Uranus rotates while essentially lying on its side. Imagine Earth spinning like a rolling barrel. Its seasons become extreme. Its orientation bizarre. Its history mysterious. Something enormous may have struck it long ago. Or perhaps something even stranger happened. We don't know. That's the beauty of exploration. Sometimes the biggest discoveries begin with admitting what we don't understand. And then there's Neptune, the outer giant. A world so distant that sunlight is hundreds of times weaker than on Earth. Yet Neptune hosts some of the fastest winds in the solar system. Think about that. A freezing planet receiving very little solar energy, still producing incredible atmospheric activity. The universe rarely behaves the way intuition expects. Most people think the solar system ends here, but it doesn't. Not even close.
Beyond Neptune stretches a vast region filled with icy remnants from the solar system's formation. This is where Pluto lives, the object that sparked endless debates about what counts as a planet. But labels aren't really the interesting part. What's interesting is that Pluto turned out to be far more complex than anyone expected. Mountains, glaciers, unexpected geology. A distant frozen world revealed surprising activity. Once again, exploration overturned assumptions. A pattern you'll notice throughout this story. Every time we look closer, reality becomes more complicated. And now, we arrive at the most important realization of all. After exploring scorching worlds, frozen deserts, gas giants, methane lakes, hidden oceans, and distant icy bodies, Earth looks increasingly rare. Not necessarily unique. We don't know that yet.
But rare. Because so many conditions seem to align here. The right distance from the sun, the right atmosphere, liquid water, long-term stability, protection from harmful radiation. A planet doesn't need just one lucky feature. It needs many. And that's what makes the search for other habitable worlds so important. Every planet we study teaches us something about our own. Sometimes by showing us what went right, sometimes by showing us what went wrong. So let's return to the question we started with. Why does Earth seem so different from everything around it? The honest answer is that we're still trying to find out. The solar system is not a finished story. Every mission reveals new mysteries. Every telescope discovers new questions. Every planet turns out to be stranger than expected. And perhaps that's the most fascinating thing of all. The closer we look at our cosmic neighborhood, the less ordinary it becomes. The planets are not just destinations. They're clues, pieces of a much larger puzzle about how worlds form, evolve, and perhaps even give rise to life. And somewhere among those answers may be the explanation for why we are here at all. Subscribe for more cosmic stories.